Whoops. That's funny. Okay, so we are working on our final review. So let's take a look at page 432, number 29 again. And that was the kite, K-I-T-E. And we talked in class about some of the properties of the kite, right? We had 4 right angles here. The diagonals bisect each other, or sorry, the larger diagonal bisects the smaller, and then the diagonals intersect perpendicularly. And this is K-I-T-E, and this is point P here where they intersect. And they gave you KP is 9 and PT is 4. And you needed to find IE. You're being serenaded. This is the tuba practice time right now. So IE, if I could find IP or PE, then I would have the whole thing. They also, I forgot to say, they also tell us we've got 90-degree angles here. Okay. So the key to this problem, guys, is to turn your paper a little bit. And now we've got a large right triangle with 2 smaller right triangles. And remember, those are all 3 similar to each other. So here's the medium. We have information about the medium. We want this side of the medium. We have information about the small. We want this side of the small. So we're going to talk about the small leg of the medium, or the large leg of the small. So the small leg of the small and the medium leg of the medium. So let's go back to looking at it like this, because my letters are this direction. So KP is to IP as IP is to PT. All right, so we've got 9 is to X as X is to 4, and you cross multiply. So 36 equals X squared, X equals 6. So that means that IE equals 12. Then they're asking for, oh, you know what, I'm going to mark these just because that might be helpful. Then they're asking for, in part B, the perimeter. So the perimeter of KITE. So we're going to need to find, actually, we know that this side and this side are congruent. So if we find one, we're good for the other. And this side are congruent. And it looks to me like we've got some right triangles. We know 2 of the sides. We're missing the 3rd. So let's use our friend the Pythagorean theorem. So let's look at this triangle here. Just for kicks, you can pick any of them. 9 squared plus 6 squared equals KI squared. So that's 81 plus 36. So that's what, 117 is equal to KI squared. Is that right? 117? Yeah. So this KI would be the square root of 117, which means that KE is also the square root of 117. Let's do the same thing for ET. So we've got 6 squared plus 4 squared equals ET squared. So 36 plus 16. So that's 452 is equal to ET squared. And then we take the square root of that. So the square root of 52, which does simplify, but I'm not going to do that right now. Okay, so to find the perimeter, we've got 1 square root 117, square root 117, so 2 square roots of 117 plus 2 square roots of 52. All right, and I'm going to take you back to your Algebra 1 days a little bit. 117, so think of the prime factors of 117. It is not prime. So let's go down here, 117. I'm doing this as a review of Algebra 1. So 3 goes in, right? Because 7, 8, 9, if we add the digits, and that'll be a 39. And 3 goes in again, so that'll be 13. So I've got 3 square root 13 here, times, there's the 2, plus 52 breaks down. I know that's an even number, so 2 goes in to 52. And so that's 26, and then 2 goes in again, and that's 13. So that's 2 square root 13 times the extra 2. So 6 square root 13 plus 4 square root 13 gives us 10 square roots of 13. Remember that from Algebra 1? I'm not really going to be stinky about that on the final, but just a little refresher of your Algebra 1 days. So that's number 29. The next problem was page 410, number 15. All right, I'm going to put myself here. And number 15, we've got a trapezoid, an isosceles trapezoid. So if you need to make a note what an isosceles trapezoid is, well, there's the trapezoid part. Whoa, you can't see it. There we go. The isosceles part is this. And then we've got a 10 here given to us, and a 16, and a 60 degrees. And they give a hint. They want us to find the perimeter of the isosceles trapezoid. The hint is to drop altitudes, plural, of the trapezoid from E and H. So E is up here, and they say H is here. So you're dropping an altitude. Remember, an altitude drops to a 90-degree angle. So we've created a right triangle here, and the same thing over here. So this is a 30, 60, 90 triangle. If you don't remember your formulas for your sides, you've got to. That's important. So 30, 60, 90. And so this is x, this is 2x, this is x square root 3 for the ratios. Okay, this is now a rectangle in here. And this is 10, from E to H is 10, so this side will also be 10. Which means there's 6 left over for either of these pieces. So 3 and 3, since it's isosceles. So x actually equals 3. And the legs of the trapezoid will be 6. So we've got to find the perimeter of this guy. I've got 10 plus 16, right? And then each side, each leg is worth 6. So there's 6 and 6. All right, we add those. We get 26 plus 12 is 38 units. All right. Next problem, page 411, number 24. I don't have to go very far. This is checking to see, do you know what to do with, oh, I think I drew it wrong. I did. The right angle's up here. There we go. So this is a right angle here, and they give us an angle bisector. So that's important to remember. And I think that's 30, not 60. That's 30 degrees. And we know from here to here is 3. Y is over here, and X is over here. So what kind of triangle is this big triangle? We've got a 90, we've got a 30, so this guy here is 60, and it's being bisected, so this is a 30 and this is a 30. So then what kind of triangle do we have down here? This is isosceles, right? So that tells me, hey, that's 3. Perfect. All right, and then look at this triangle, the smaller triangle. This is 90, this is 30, so this must be 60. So let's see. We're going to talk about, I don't know, X first if you want. It's totally your choice. Let's go with Y. I think Y is easier to start with. So we've got a 30, 60, 90 here. Let me redraw it for us. There's the 90, there's the 60, there's the 30. This is the Y. This is 3. So let's remember our ratios. This would be the X. This is the 2X. This is the X square root 3 side. So X, not this X, by the way, different X, equals 3 halves. So this guy here is 3 halves, or this one's 3 halves, they're the same. This one here, Y, is going to be 3 halves square root 3. So y equals 3/2 square root 3. Okay, so we found y. Now let's search for x. We went ahead and said this is a 30, 60, 90. And so we've got the ratio of the sides. So I'm going to erase this x because it's kind of, well, the ratio is across from the 30 is our x, if you will. Across from the 60 is our x square root 3. And across from the 90 is 2x. This x and this x, not the same x's. I am sorry for that confusion. We could have used s, I suppose. So anyway, across from the 30, we know this piece here. So we need this piece here. So it's twice this. So 3/2 square root 3 times 2. 2's divide out. So 3 square root 3 is what the x of this triangle that I should not have labeled. Well, that's what the book labeled it though. So there you go. All right. That was 411. Now we're going to go down to page 164, number 18. And I'm having you go down there because I want you to remember how to prove triangles congruent. You will need to build on that on the final. 164. Okay. And my son's getting ice. It's all right, buddy. You can do that. I'm just going to draw a picture. Thirsty. Alrighty, we've got, this is our picture. A, B, C, D, E, 1, 3, oh, this is F. And we are given that we have triangle, no, wrong one. AC is congruent to BC, and angle 1 is congruent to angle 3. We want to prove that triangle DFE is isosceles, which means we need to show two congruent sides, right? That's what we need to show so that we can say it's isosceles. Let's mark our picture. This side here, congruent to this side here. 1's congruent to 3. So, if 1's congruent to 3, then we know, let's see, DC is congruent to EC. I'm just going to kind of do a sketch proof. Because if the base angles are congruent, then the sides are congruent. And we could also say that AD is congruent to BE by subtraction. So I've got this piece is congruent to this piece. Now I probably want to show like these guys are congruent to each other. That's probably where I'm headed with this. So if I've got a side here and a side here, we could say that these angles here are congruent, couldn't we?